Hi, this is John, and welcome to another edition of Statistics Tell a Story. Well, football season is around the corner, and I will be doing my weekly episodes. But before I get into that for each week, I wanted to explain what a model is. You hear a lot of talk about models, and in fact, if you follow any of the YouTube podcasts, you'll see people referring to models. Like, for example, somebody on Action Network might say, my model predicts 9.2 wins for the Pittsburgh Steelers. So I wanted to give just a basic explanation of what a model is and go over a routine example and then expand on that a little bit towards the end. A model is really a formula, and it's used to either explain or predict. Usually the context is to predict, and in fact that's what you probably hear a lot of times, again, whether it's stock market, football, whatever. It can be very basic. For example, I made up something very basic. Let's just say you want to predict the high temperature for a day, okay? And say, well, I don't really know what exactly to incorporate for my model. I'm just going to use yesterday's high. Well, that's a model. It's a very basic model. And it's going to be probably pretty close, right? Because if you have August 29th on one day and August 30th the next day, well, it's still the same season. One day later, you're probably going to be pretty close. All right, getting back to football. So let's say we want to predict wins for a team. We might run what's called, many of you are familiar, you've heard the term at least, a linear regression. Actually, linear regression has the word line in it, and I'm not going to get real involved, but if you've ever taken a basic statistics course in class, you have some idea of what's involved in a linear regression. So let's say that we want to predict wins of an NFL team, and we're going to use a basic one, and we're going to go back the last 3 years and look at their wins for the last 3 years. And we have an intuitive idea, intuitive sense, that using the wins of the last 3 years will help us predict the wins this year, right? Not that I have to go back 3 years. That's an arbitrary decision. Some might go back 2 years, some might go back 4 years. I'm going to go back the last 3 years. So how do we do that? We use what's called a training set. And that's the data that's used to create a formula. And actually, again, in a stats book, they have kind of the behind the scenes work that does that, but nobody bothers doing that today, especially with the internet and Excel and so forth. You can basically push a button and you're able to do that. Of course, you do need the data, but that's not so hard to come by, again, especially in particular with the internet. The data for many things, a lot of times it's free, sometimes you have to pay for it. No, so I did this. I actually have a database for wins. Actually, it goes back to, for teams win each game during the season for all the teams back to, I think it's like 1980. So I use a training set. I actually went from like 1980 to 2020. So that's a very big sample size, many years, and I found, or at least the computer found, or you can do this on Excel, the wins for a given year was equal to 4.18 plus 0.22 times the previous year wins, I have pre-1, plus 0.23 times the previous second year previous to that wins, plus 0.04 times previous 3, which is the third year prior to that. So a couple of things we might note. First of all, one thing we can say is, well, if a team won 0 games this year, and this year, which has never happened, and we plugged in 0 for each of these, we would still predict them to win 4.18 wins the next year, which, might be reasonable, might not be. I recall one year the Browns went 0-16. I think they followed it up, or they preceded it with a year, I think they went 1-15, and then the next year they just you probably heard the expression regression to the mean. Well, you can't do much worse than that, and so just even filling out your roster with some decent players might help you win 3 or 4 or 5 games. I don't remember how many they won, but they kind of shot up. I don't want to say suddenly, but all of a sudden they were in the playoffs a couple of years later. But anyway, so when you run a model, you'll get p-values associated with these coefficients. A p-value basically tells you how confident you can be in that coefficient. The smaller the p-value, the more trust you might say you have in that coefficient. For this particular one, I didn't list the p-values. I will tell you that the p-values for these two coefficients were very nearly 0, which means this is a pretty good indicator, pretty good basic indicator, coefficient-wise. This p-value was, I believe, 0.35. Statisticians have a little bit of a debate when you have p-values that are beyond, say, 0.10, or some even beyond 0.05. My experience has been to keep it in. Okay, p-value is 0.35. Why would I keep it in this case? Well, to me, it's better to use than not use. But a lot of statisticians, they want to be more pure. You might say, well, you know what? It's kind of a weak indicator, so we're not going to use it. That p-value of 0.35 tells us it's kind of weak. But to me, I'd rather use something weak than not at all. It's not as if it drags it down. Somewhere, actually, I'm gonna jump ahead here for a second to MAE, and then I'll get back to this. MAE is mean absolute error. So we can look at the error in which we use our test set, which I didn't get to, so test set. So I use a test set of the years 2021 to 2024. And we can say, okay, how well would our prediction do to what actually happened? We know what happened in 2021, 2022, 2023, and 2024. So in fact, we might even do this a couple ways. You might say, well, we're going to run it without this, and we're going to run it with this, and we're going to find our mean absolute error of what actually transpired between the predicted value and the actual value in this particular time period. Again, I didn't actually compare this, but in most cases, I'd rather put this in. The smaller the mean absolute error, the better your prediction is. So you do this. You have a test set. Now you're testing what you found, and if you're happy with your mean absolute error or how well it predicts, then you might use that to predict for 2025. Okay. Now, being happy with a mean absolute, that's a relative thing, isn't it? So you might go back and say, well, let's look at what the test set did in 2021 to 2024. Let's just say it picked the Baltimore Ravens, who are pretty good every year. Let's say that it predicted them, depending on the formula, to win, 7.8 games. And you might say, wait a second, this is not reasonable. So one of the things that us statisticians do with models is we're continually tweaking, and we're continually maybe saying, well, okay, let's it's almost like baking a pie. Let's try a little bit of this, a little bit of that. Okay, so for example, I have a very basic one. I say, well, let's say we want to predict Green Bay for 2025. Well, I'm going to plug in the information into this formula, right? It's like plugging into a recipe. So the predicted wins for 2025 is 4.18, or sometimes we call that our constant, plus 0.22 times the wins previous one, which means last year's wins, 2024. They won 11, 0.23, they won 9 the year before, 0.04, they won 8 the year prior. We get 8.99 wins, actually pretty reasonable. If you look at some projections for Green Bay, a lot of them I think are the over-unders, which I'll hopefully get to Monday, is like 9.5 wins. Now, this was very basic, okay? But it's a start. It does not involve many things. For example, strength of schedule, right? Maybe they played tough schedules here. Maybe they played easy schedules. It does not involve metrics. Metrics are very important. For example, the San Francisco 49ers come to mind. Actually, several things for last year. They had a very down year, but their metrics actually reflected a good team. There are different metrics like success rate, things like that. Football Outsiders has something called DVOA. I believe that they were in the top 10 in offense and defense DVOA. Plus, they were very injured. So there's 6 wins. We probably wouldn't, if we did something like this with San Francisco, we would actually kind of downplay their prediction for 2025 because we're missing a lot of things, right? Player movement and coaching changes in some cases. Okay. Then as we go along and we maybe involve some of these things, we get a little, it kind of becomes a chess game a little bit. So then there are other things that, if you're an advanced statistician, which I consider myself, don't know everything, but I know my share. Then there's certain things like collinearity, which basically collinearity is where 2 independent variables, these are independent variables, are related to each other or they're correlated to each other and they kind of end up conflicting and it can mess up your model. Okay, so those are kind of some things to anticipate. There is a saying, I forget who said it, but he basically said that all models are wrong, but some are useful, right? No model's ever going to be perfect. What you'd like to, what we aspire to is to get an optimal model or basically the best possible model that we can get. Go back to that MAE, and there are different ways that you can actually gauge your models. MAE is just one of them. It's a very basic one. It's basically how far off are you from the predicted. So for example, let's say that we go back to our test set and we have a particular team and we predicted 11.2 wins and they won 10 wins for that particular year. What is the absolute value of 11.2 minus 10? It's 1.2. So that would, and we would take the average of all of those values. So mean absolute error, that's where MAE comes from. Okay, and then I'll end it with this. There are different types of regression. So for example, linear regression may not work for everything because maybe, some things are linear in nature, it's the most common, but I've done linear regressions, sometimes for wins, but you might, depending upon the team, it's possible to predict more wins than our games in the season. Very rare, but it could happen. So you might have to adjust. You might adjust coefficients and try to stay linear, or you might do some fancy things. There are logistic regressions. There are versions of linear regressions like lasso and ridge, which I'm not going to get into. Maybe that'll be for the future. For example, ridge, I will mention, it will actually shrink coefficients. So let's just say you have a coefficient that you think is pretty good, but maybe it's just too strong of an indicator. And you feel that it's, with that strong indicator, maybe it's average yards per passing. Okay, and somebody was really good. Tampa Bay comes to mind. Baker Mayfield had a really good year, and maybe you're thinking, what, I'm using this variable, which I definitely believe in, but it's distorting things a little bit. I'm going to rein in that variable a little bit, and so you might do it by a ridge regression. That's just an example. But anyway, so I hope this gives you a flavor for what a model is. Again, a model is really just a formula, and that formula, you plug into the formula, it spits out a prediction, and that is basically what a model is. Again, please tell your friends to tune in, right? It's free. If you haven't hit subscribe or like, please do so. It's much appreciated. I will be back next week for sure with my week 1 predictions, and I hope to have over-unders actually for all 32 teams. But until then, next time, see you on Statistics Tell a Story. Thank you.